Welcome back to the channel. In the first video, we covered the basic concept of limits, and today we are diving into two very important limits that come up all the time in calculus. That is the sin x over x is equal to 1 and tan x over x is equal to 1 as s approaches 0. These limits are essential tools for solving a wide range of problems, especially when dealing with trig functions. In this video, I will show you how to use these limits to simplify complex expressions and solve problems quickly and efficiently. Understanding these key limits will make your problem-solving process a lot easier, whether you are working with derivatives, integrals, or just evaluating limits directly. So let's jump right in and see how we can apply these properties to solve some challenging questions. First of all, let's look at these theorems, right? So the first one is, if we have limit as x approaches 0 of sin x over x, this will always be equal to 1. Also, note that if we have if we have x over the sine of x, this will also be equal to 1. The second one is, if we have limit as s approaches 0, now instead of sine x, we have tan of x out of x, this will also be equal to 1. And the limit as s approaches 0 of x over tan x, this is also equal to this is also equal to 1. Now let's look at the first question. For the first question, we have to show that limit as x approaches 0 of sine of 2x out of 5x is equal to 2 out of 5. Let's solve the problem. So limit as s approaches 0 of sine of 2x out of 5 out of x. Note that the key idea over here is we always want this angle right here to be the same thing over here. So what do? We can have limit as s approaches 0. Note that sine of 2x over 5x can be written as this. So now the next thing to do is we can divide sine of 2x to make it 1. We can divide by the angle. Now if you divide by the angle, you have to multiply by it. Remember, if we are to divide this and this, we get what is over here. So we've not changed the question. It is the same thing. Then we multiply it by 1 over 5x. So we can have limit as s approaches 0, sine of 2x over 2x. Then if we multiply 2x and 1 over 5x, we have 2x over 5x. Now from the first video, remember that there is a property that says that if we have something like this, then we can distribute the limit. So we can have limit as s approaches 0 of sine of 2x over 2x times the limit as s approaches 0. Now in this case, we can see that this x will cancel this x. So we just have 2 out of 5 left. Now using the property that we know, this over here goes to 1. So we have 1 multiplying limit of a constant is always a constant. So we have times 2 out of 5, and this is equal to 2 over 5. So this is our answer. I hope this is clear enough. Let's move on to the second question. For question 2, we have limit as t approaches 0, tan of t times secant of t, secant of 2t out of 3t. So the first thing to do is we can break this into parts, right? We can have limit as t approaches 0. We can have 1 over 3t times. Now note that tan of t is equal to sine of t over cosine of t. And now secant of t will always be equal to 1 over cosine of t. So over here, instead of secant of t, we have secant of 2t. So this is 1 over the cosine of 2t. So we have tan of t, which is sine of t over cosine of t, multiplying secant of 2t, which is the same as 1 over cosine of 2t. We can now bring 1 over 3 over here outside, right? So we can write it in front. Remember the properties, right? So we have just 1 over t sine of t over cosine of t over cosine of 2t. So in this case, limit as t approaches 0, what can we do? Remember, 1 over 0 is undefined. We can't have that. Sine t over cos t, can we simplify that? So since this is going to be a problem, we can swap it, right? So we can have 1 out of 3 limit as t approaches 0, then sine t over t multiplying 1 over cosine of t multiplying 1 over cosine of 2t. So now, not to have an undefined answer, we swapped sine of t and 1. Since it is a fraction, it doesn't change anything. It's the same thing, right? So we have 1 out of 3. Remember, we can distribute limits. So limit as t approaches 0 of sine t over t multiplying limit as t approaches 0 of 1 over cosine of t times limit as t approaches 0 of 1 over cosine of 2t. So we have 1 over 3. Now we know that this part right here, this goes to 1. So we have 1 multiplying. Now if we put in 0 right here, cos of 0 is 1. So we know that limit of a constant is that constant. So we have 1 here. The same thing, if we put in 0, 2 times 0 is 0. Cos of 0 is 1. 1 out of 1 is 1. And the limit of a constant is 1. So we have 1 here. So our final answer in this case is just going to be 1 over 3 multiplying 1, which is the same as 1 out of 3. Let's move on to the third one. We have to find the limit in, the first one is limit as s approaches 1 from the right of x minus 1 over x plus 2. Whenever you have limits like this, that's what we call the one-sided limit, right? So it works just as the normal limits that we know. The first thing to do is put in the value. Note that 1 plus doesn't necessarily mean anything greater than 1. It means 1, right? So in this case, we have to first evaluate it at the value indicated here, 1. If we have a problem, that is where we consider the sign. So we have limit as s approaches 1 from the right. Then let's put in 1. If we put in 1, we have 1 minus 1 over 1 plus 2. So this is going to be limit as s approaches 1 from the right. We have 0 over 3. Remember, 0 over 3 is still 0. So square root of 0, and this is just equal to 0. The second one is, if we have limit as s approaches minus 2 from the right of x out of x plus 1, then 2x plus 5 out of s squared plus x. Now, using the same idea, we have to evaluate it at the value in question. So we have s approaching minus 2 from the right. We just put in minus 2. So minus 2 plus 1, 2 times minus 2 plus 5, minus 2 squared, then minus 2. So we have minus 2. Minus 2 plus 1 is minus 1. 2 times negative 2 is negative 4 plus 5, we have 1. The negative 2 squared is 4. 4 minus 2 is just 2. So in other words, we have just negative 2 out of negative 2, which is equal to 1. And this will be our answer. I hope this is also clear enough. Now let's move on to the fourth question. For question 4, we have to find the limit as x approaches 0 of tan of 2x out of x. Now note that limit as x approaches 0 of tan x over x, this is equal to 1. Meaning that the angle over here should be the same as the one here, right? So that's the goal. We want the angles to be the same. Now, how do we do that? Since in our question we have x approaching 0, the angle in this case is 2x. We can now introduce 2x over here, but do not forget to multiply by 2x. This is because if we are to cancel this and this, we just have our tan 2x. We've not changed anything. So that's how to do it. But remember, we have an x in the denominator, so we can write it as 1 out of x. Now we can have limit as x approaches 0, tan of 2x out of 2x. We can multiply these two right here. So we have 2x out of x. Using the properties of limit, we can just distribute the limit. So we have this. Note, x can cancel x right here. So we just have 2 left. Now using the property, this over here is equal to 1. So we can have 1 multiplying. Now limit as s approaches any value of a constant is that constant. So in that case, 1 multiplying 2. So this is equal to 2. I hope this is clear enough. Let's look at another one. So for question 5, we have limit as s approaches 0 of tan of 3x over sine of 8x. Remember, the goal is to always make the angle the same as the one in the denominator. So we can first of all rewrite this as limit as s approaches 0 of tan of 3x multiplying 1 over sine of 8x. Now we can divide tan of 3x by the corresponding angle, which is 3x, but we have to multiply it by 3x. To make this equal to 1, we have to multiply by 8x. So we can have 1 out of sine of 8x multiplying by 8x out of 8x. This is because we know that limit as s approaches 0, remember, of x over sine of x is equal to 1. So in this case, since we have 8x over here in the denominator, we can multiply by the angle, which is 8x, to make it 1. So that is the idea. So we have limit as x approaches 0, tan of 3x over 3x times, we multiply this 2 right here. So we have 8x.
To who?
So we have times limit as s approaches 0, 8x over sine of 8x times, now we can multiply this and this, right? So we have 3x. We have limit as s approaches 0 of 3x out of 8x. We get to see that this is equal to 1. This is also equal to 1. Over here, the x and s cancels, right? So all you have left is limit as s approaches 0 of 3 out of 8. So that is a constant, so we have 3 over 8. And if you multiply these 3, we have 3 over 8 as our answer. This is our answer. I hope this is clear. Okay. Let's move on to the next one. Now we have limit as x approaches 0, s squared minus x plus sine x all over 2x. Now to solve this question, first of all, we can put inside the function, we can evaluate it as 0, right? We have 0 squared minus 0 plus sine of 0 out of 2 times 0. Remember, sine of 0 is 0, so the numerator just goes to 0, the denominator is 0. This is an indeterminate form that we don't want. So how do we do it? We can rewrite the expression by dividing each term by the denominator, right? So we have s squared out of x minus x out of 2x plus sine x out of 2x. Now we can distribute our limits. So we have s squared over x minus x over 2x plus sine x out of 2x. Now note that s squared over x right here simplifies to x. This just simplifies to 1 over 2, right? So we can have limit as x approaches 0 of x minus limit as x approaches 0 of 1 over 2, then plus. Remember, since this is x, we want the angle to also be x. So we can bring 1 over 2 outside, then we have limit as x approaches 0 of sine x out of x. I hope this is clear enough. So now let's go ahead to simplify. So to simplify this, if we put in 0 right here, that goes to 0. Limit of a constant is that constant, so we have 1 over 2 plus 1 over 2, but this right here is equal to 1. So if we multiply by 1, we get the same thing. So we have 1 negative 1/2 plus 1/2. So this is just equal to 0. I hope this is clear as well. So these are some of the ways to solve questions like this. Let's move on to the next one. We have limit as x approaches 0, x plus x cosine of x sine x cos x. Now let me give you some time. You can pause the video and try to do it on your own, right? Let's say you have 10 seconds to pause the video and now do it on your own. Assuming you are done, let's go ahead to solve the problem together. So first of all, if we put in 0, we have 0 plus 0 cos of 0. Now sine of 0 cos of 0. So we have 0 plus cos of 0 is 1, but 1 times 0, we have 0. Sine of 0 is 0. Cos of 0 is 1. So this is just 0 out of 0, which we don't want. So what do? We can do the same idea just as the previous question. We can divide each term in the numerator by the denominator. So we have x out of sine of x cosine of x plus x cosine of x out of sine of x and cosine of x. Remember, this can cancel this. So we have limit after distributing, right? Let's distribute it straightforward. Sine x cosine x plus limit as x approaches 0 of x out of sine of x. Now, how do we solve this first part? For this, we can break it down into 2 again. We can have x over sine of x multiplying 1 over cosine of x. Then plus our limit as x approaches 0 of x over sine of x. Using the property, we can have x over sine of x multiplying limit as x approaches 0 of 1 over cosine of x plus limit as x approaches 0 of x over sine of x. Note that this is a property, right? So this right here goes to 1. So we have 1 multiplying. If we put in 0 right here, we have cos of 0. Cos of 0 is 1. So 1 over 1 is 1. So we have 1 here. This also simplifies to 1. So we just have 1 by 1 is 1 plus 1. This is equal to 2. And this is our answer. For the next question, we have limit as t approaches 0 of sine of 1 minus cosine of t out of 1 minus cosine of t. Now to solve this question, first of all, let's put in the 0. If we do that, we have sine of 1 minus, now cosine of 0 is 1. In the denominator, we are going to have 1 minus cosine of 0, which is also 1. So we have just sine of 0 out of 0. And sine of 0 is 0. So we have an indeterminate form. But note that we have a property that says that limit as t approaches 0 of sine t over t, and this is equal to 1. So using that idea, right, the angle which is over here should be the same thing as over here. Looking at our question, we can see that the angle is 1 minus cosine of t, and the value in the denominator is also 1 minus cosine of t. So since these two are the same, without even solving the question, we can go ahead and say the limit as t approaches 0 of sine of 1 minus cosine of t over 1 minus cosine of t, this is just equal to 1. And that's our answer. Now let's look at the last question. We have limit as x approaches 0, 1 minus cosine of 3x out of 2x. Now, so far, we've been dealing with sine and tangents, right? But to solve this, note that one property is also limit as s approaches 0 of 1 minus cosine of x out of x, this is equal to 0, or limit as s approaches 0 of cosine of x minus 1 out of x, this is also equal to 0. So basically what it means is that we have to adapt our question to this property. So looking at this, the angle right here is the same as this, right? So we have to do the same thing to our question. So we can have, since our angle is 3x, we can divide by 3x, but we shouldn't forget to also multiply by 3x. Then multiply it by the denominator, so we have 1 over 2x. So we have limit as x approaches 0, 1 minus cosine of 3x out of 3x multiplying. Now we can multiply these two guys, right? So we just have 3x out of 2x. Then we can go ahead to distribute the limit. We can divide this and this, so we just have 3 out of 2. Now using the property, we know that this right here is equal to 0. So this is just 0 times. Now the limit of a constant, that is the constant itself. So we have 3 out of 2. Multiplying these two, we get to see that our answer is just 0. So this is how to use the basic property of sine x over x, tan x over x, and also cosine to solve questions like this. If you have any problem, reach out to me in the comments and I will gladly answer you. I would also appreciate it very much if you like the video, share and subscribe as well. Thank you very much. I'll see you in the next video.